Welcome to qnawire.
In part A of this problem, we're asked to find the acceleration of a process. The process has an initial velocity of 0 meters per second because it starts out at rest. It has a final velocity of 224 meters per second. The time it takes to reach that speed is 0.9 seconds, and the acceleration is unknown. To find the acceleration, we can use the kinematic equation v is equal to v naught plus a times t. Plugging in our values, we get that the acceleration is equal to 249 meters per second squared. And that's the answer to part A. Part B is asking us to convert that acceleration into g's. Recall that the magnitude of 1g is 9.8 meters per second squared. So the answer to part A we got was 249 meters per second squared. So we can figure out how many g's we have by dividing this by the magnitude of g, which is 9.8 meters per second squared. And that'll give us the amount of g's. When you plug this into the calculator, you get that it's equal to 25.41 g's. Part C is asking for the distance traveled during this process. And to answer that, we can use the kinematic equation x minus x naught is equal to v naught times t plus 1/2 acceleration times time squared. X minus x naught is the distance traveled, and that is our unknown. So we're going to be solving for the left-hand side by plugging in values on the right-hand side. V naught is 0 because this object starts out at rest. And the acceleration we calculated in part A, so we can just plug that in. We found that it was 249. And then the time they just give us as 0.9. And then when you plug this into your calculator, you get 100.8 meters. And that's the distance traveled in 0.9 seconds. The last part of this problem asks whether a magazine was lying when they said that the deceleration of this was greater than 40 g's. So in this case, our initial velocity is 283 meters per second. Our final velocity is 0 meters per second. The time of this deceleration is 1.4 seconds. And to figure out the acceleration, we can use the kinematic equation v is equal to v naught plus acceleration times time. And so 0 is equal to 283 plus 1.4 times a. And thus a is equal to negative 202.14 meters per second squared. Dividing by 9.8 as we did in part B to get the number of g's. So if we just divide this by 9.8, we get that the acceleration is negative 20.63 g's. And so I believe the magazine was saying it was greater than 40 g's, and that is not true. So the magazine lied to us. Their claim is not true. The magazine is not true. So say the magazine's claim was not true. And that's the end of the problem.